Hello friends, welcome to engineering tutorial. Now in my previous videos I discussed about the working principle of NPN and PNP bipolar junction transistors, the various concepts related to current conduction in NPN and PNP type BJT, and the majority and minority charge carriers involved in current conduction. And I also discussed about the movement of electron and holes in general, and in reference to the majority and minority charge carriers involved in bipolar junction transistors. So in today's video we will be discussing about the various circuit configurations involving bipolar junction transistors, that is the various ways in which BJT can be connected in a circuit. Okay, so let's get started. So we know that there are three leads or three terminals in a transistor device: the emitter, base and collector. But when a transistor is connected in a circuit, we need two pairs of terminals, that is total 4 terminals, 2 for input so that we can apply the input signal, and 2 for output for taking or extracting the output. So in order to accomplish that, the transistor or the BJT has to be connected in a certain way in a circuit. Now this problem is solved by making one of the terminals or leads of the transistor common to both the input and the output terminals. Okay, so one terminal acts common or is common to both the input and the output circuit. Okay, so as the BJT has 3 terminals, so there can be 3 possible ways in which a BJT can be connected in a circuit. So we have 3 types of transistor connections or transistor configurations. First one is the common base configuration or the common base mode BJT, in which the base terminal is common to both the input and the output circuit. Second is the common emitter mode, in which the emitter terminal is common. And last, the common collector mode, where the collector terminal is common to both the input and the output circuit. So here we have the BJT, which can be connected in a circuit in 3 ways: common base, common emitter and common collector. Now in today's video we will discuss about the common base configuration or common base mode connection of BJT. Okay, so this is how BJT is connected in common base mode. Here we have the bipolar junction transistor. It is a NPN type BJT. How we know that it's NPN? Always pay attention to this arrowhead. It's directed outwards. It means that it's a NPN BJT. The emitter current is directed outwards, the base and collector currents are directed inwards towards the BJT. Okay. Now here, notice that this base terminal, it is common to both the input towards the left, this is the input terminal, and it is also common to the output towards the right. Okay. The base terminal is common to both the input and the output. Now here the input junction is the emitter base junction, emitter and base. It is the input junction, while the output junction is the collector base junction towards the right, the collector base junction. Now there are some important points associated with the common base configuration. Okay, so all the things are mentioned here, you can note them down. So some important points are the base is common to both the input and the output. As I said, the emitter base junction is the input and the collector base junction is the output. Here VEB and VCB are the forward and reverse bias voltages. Here the input junction, the emitter base junction is forward biased. As you can see, the N terminal is connected to the negative end of the supply, and the P-type base is connected to the positive end of the supply. And here the output junction, the collector base junction, is reverse biased. The N-type collector is connected to the positive end of this supply, and the P-type base is connected to the negative end of the supply VCB. Okay, this is the input signal which is to be amplified or which is to be processed by the circuit. Okay, and the output is taken across this collector resistance RC, across the collector base junction. So here it is the common base connection of BJT, where the base terminal, this is common to both the input and the output. Okay, so please note down these important points if you want to, and draw this diagram. Next, now there are some important parameters associated with the common base configuration of BJT. We will discuss them one by one. Now the first important parameter associated with the common base mode BJT is the current amplification factor. That is the current amplification factor for common base mode. It is denoted by the symbol alpha. So wherever you see alpha, it means the current amplification factor for common base configuration. Now in the common base configuration, here again in the common base configuration of BJT, here another important thing is that the output current here is the collector current, and the input current is the emitter current. Okay, collector current is the output current IC, and IE emitter current is the input current. So these two things are related or will be used while determining the current amplification factor for common base configuration, the input and the output current. So as I said, the output current is the collector current and the input current is the emitter current. So the current amplification factor is basically the ratio between the collector current to the emitter current, or the change in collector current to the change in emitter current. In all the configurations, BJT configurations, this definition will always stay. It means the definition will be, or the basic definition of current amplification factor for any configuration of BJT is the ratio between the change in output current to the change in input current, where the output and input current will vary for different configuration of BJT. Now for this common base configuration, the output current is collector current and the input current is emitter current. That's why it is the ratio of the change in collector current to the change in emitter current. So you remember this as the ratio of the change in output current to the change in input current. Now this is the collector base voltage, which is the output voltage. So at constant collector base voltage or at constant output voltage. Okay, so here we have the current amplification factor for common base configuration of BJT is the change in collector current to the change in emitter current at constant collector base voltage, or you can remember this as for any configuration of BJT, the amplification factor, the current amplification factor is the change in output current to the change in input current at constant output voltage. Okay, that is the basic definition. Now the value of current amplification factor for common base mode, that is alpha, is always slightly less than 1. Okay, that is because we know that the collector and emitter current are almost equal, isn't it? Because only a small amount of current is lost because of electron hole recombination in BJT. I have mentioned that the collector current is almost 95% of the emitter current. So whenever you determine the ratio, it will always be less than 1, because IC is slightly less than the emitter current. The collector current is slightly less than the emitter current. So the ratio will always be close to unity, but not exactly 1. Okay. Now the practical values, they range from 0.9 to 0.99, the alpha value or the current amplification factor for common base mode BJT. Okay. Now the next important parameter associated with common base configuration is the collector current expression. Okay, the output current, the collector current. Now the collector current in common base configuration, it consists of two parts. Okay, now the first part is because of the emitter current from the input, from the emitter base junction, which reaches the collector base junction after electron hole recombination in base. Okay, that is the first part. The second part is because of the leakage current. Okay, now the leakage current is because of the minority carriers. Now for NPN type BJT, the minority carriers are holes. For PNP type BJT, the minority carriers are electrons. So this leakage current flows due to minority charge carriers across the reverse bias output junction or the collector base junction. Okay, this is the leakage current in common base configuration. It is the collector to base leakage current when the emitter circuit is open. Okay, here the emitter terminal, this is open circuited. So when this condition is achieved, a current flows from collector to base terminal, which is called as the leakage current. Now this forms the second part of the collector current. It is of negligible value. So it's sometimes, most of the time, it's ignored. So the first part of the current, which relates the current amplification factor value, is IC is equal to alpha IE. This is because of the first part, that is the emitter current which reaches the collector terminal. Now the second part is the leakage current, which is the collector to base leakage current when the emitter is open, this one. So we understand that the collector current in common base mode BJT, which is the output current, it has two parts. First, this alpha IE part, which is because of the emitter current, and the second part is the leakage current, which is the collector to base leakage current, which flows when the emitter terminal is open circuited. It is because of the minority charge carriers. Okay, so this is the final expression of collector current, which is equal to alpha IE plus I subscript CBO, which is the leakage current. Now this is of very negligible value, so it is ignored in most cases. So here we have discussed about the transistor connection configurations and also some of the important parameters associated with the common base configuration of BJT. Now in my next video, I will discuss about the characteristics or the voltage current VI characteristics of common base configuration of BJT, and I will also be discussing about the common emitter and common collector configurations in my future videos. So please subscribe my channel Engineering Tutorial for more such videos related to electrical and electronics engineering. Have a great day. Thank you very much.